Okay, welcome to Verkle Implementers Call number 2. We have a few things on the agenda today, so we can just jump right in. Guillaume, do you want to kick things off?
Yeah, sure. So I'll give a quick update about the work I did on overlay. I was going to share my screen briefly. Here we go. Right. So I updated the like the document created by Perry about the transition to start giving some benchmark related to the overlay. They're still like tentative, but it looks like on a fairly modern but not so modern machine like a Ryzen 7, so it's not yeah, it's a few years old. Actually, I'm not quite sure how old it is, but it's definitely not latest generation. I tried to convert 1000 nodes per block and 10K. So the estimate is that with 1000 node per block, sorry, 1000 leaf per block, it would take about 5 months. And it takes on average 15 milliseconds to do the conversion. So for 1000 nodes, sorry, 1000 leaf. And the worst case I've seen was 30 milliseconds, but it really didn't happen often. So that's a good basis. Of course, it lasts about like 5 months, but yeah, I'm of the opinion this is acceptable. I'm interested in hearing some feedback about this. I also tried 10K, which would be the like the worst case that I'm like, yeah, the worst I'm willing to go per block, and it's still 120 milliseconds on average. So it tends to even out when you start inserting more keys per block. That would take 15 days. So I think that's 10K is still. I'm not sure most of the network can achieve that, but 5K at least looks feasible.
I think, for based on these numbers, I would definitely go for 10K.
Mm-hmm.
And the reasoning is, I feel like can't we just do this conversion between slots? Like
Yes.
we don't have to add this to the block processing time, but we
Mhm.
do it before the next block is processed completely.
Yes.
So we already have all the data, so it basically doesn't add anything to like execution latency and so on. It's just like something extra you have to do after you've verified the block, right?
Absolutely. Yeah, so that's definitely an option. It's not
So
implemented yet.
then I would rather like have a bit more, because that is still quite a small number, right? That's like, yeah, like it's doubling the load per block. Okay, fair, but that would only matter while you're syncing.
Yeah.
So instead of after, I would say before a block, and then the block would go in, because we also need to verify Verkle root, right? So it's part of consensus.
Right. I'm saying like, yes, like logically it would be before a block, but that means like in terms of causality, you do the work after you've just processed the block, right? So I process a block and I can immediately do the work for the next block. That's what I'm saying, because I know exactly like what's going to be the start of that block.
Yeah,
Yep.
yeah, I'm just pointing out that it has to be in consensus.
Yes, it's still in consensus. It's just logically at the start of the block, so you can exactly predict what work you're going to do.
Yep. No, but I agree that would be the optimization. The question is still, so what's missing from this benchmark is what happens on a low power machine like the ROG 5B, which I think represents the lowest machine we're willing to support, the most under-spec machine we're willing to support. So that's the question. Like, can they still do 10K leaves within a reasonable time, like let's say 6 seconds?
Does this add anything to RAM requirements?
Sorry?
Does this add anything to RAM requirements, storage? Memory?
No, memory requirements, no. It's really computing power.
Yeah.
So,
Right. Yeah, Lukasz?
question: was this a test on mainnet database?
Yes.
Okay, very good. Yeah, so I think we should try to run it on Rocks 5B.
Yeah, agreed. I just ran a bit of time. Sorry, I ran out of time preparing for this, but yes, that's one of the goals.
Okay.
And yeah, so those numbers, to run those numbers, I replayed roughly 2 million blocks. So I started a bit like before around block to get those numbers around block 1400. Sorry, 14 million. But yeah, so far there are still a couple bugs, but replaying to 2 million blocks gives me confidence that that this works well enough. So yeah, I mean, I'm willing to hear other people's opinion, of course, but in my view, I think the overlay method is is the way to go. Yeah, and so that was pretty much it for my update.
So this still, I mean, what the still can we clear storage while we are doing this? So like, would you be able to clear the storage used by the MPT at the same time?
Not exactly at the same time, because we need to reorg.
Roughly.
Yes,
within
exactly.
like a day or something.
Exactly. So that's the plan. Well, the first thing you can do as soon as the transition start has passed finalization is delete all the internal nodes of the tree. Right. All you need is the leaves. Like most clients, at least I'm saying most. I'm not sure actually, but Geth and Besu, and presumably Aragon at least, have a flat database. Lukasz, I'm not sure if you guys have rolled out Paprika yet. Do you have?
No. It's still development, but I think it will be before Verkle 3, definitely.
Right. So in that case, if you have the flat database, if every client has a flat database, yeah, like storing its data, its leaf data into a flat database, you can already start with deleting the entirety of the internal nodes. And then, because it's predictable what gets deleted, what gets converted from the MPT inside the Verkle tree, you can start deleting nodes, like you said, with a bit of a buffer, so that you are able to reorg. But yeah, you would be able to delete the data. My prototype does not have that yet, but that's really not difficult to implement.
Tanishq?
For the deletion part, I think obviously it does not matter in the protocol, but we should have a kind of a soft offset on when we start deleting the data, so that we don't happen to be in a case where the transition went wrong and client does not have the initial Merkle tree. That would be a huge problem, I guess. So I think we can probably do something like wait for a day or two and then start dealing the internal nodes or the converted data.
Yeah, that's. I mean, at least that's how I understand it. I was just going to say, let's wait for the finalization point, but we can be even more cautious by waiting a couple of days for sure. Yeah.
There's a question in the chat from Karim.
Yeah.
When do you think we will have a consensus regarding the transition mode, overlay, or something else? Guillaume, if you have thoughts.
I mean, yes, I have thoughts. Is when you agree this is the way to go, and every other client agrees this is the way to go.
Thanks. I mean, to be fair, I mean, let's just put up some document. I mean, the issue is, of course, that the overlay method or transition method actually has a bunch of minor, it's more of a spectrum of methods which can fit actually multiple things, but fairly certain we will end up with some way of some overlay-ish thing.
Yeah, I would say like based on this, currently I would just like say commit to doing the overlay until we find something that's some unsurmountable hurdles, and then we can think again. But I think like it's best to just try to push one method and yeah, give everyone some certainty about that.
Okay, maybe that's a good segue for agenda item number 2. Gottfried, you put together some notes on the transition?
Yeah, I mean, I just wanted to collect some kind of thoughts that I had. I mean, I'm not sure whether you all have the a link. Maybe you can share some link.
I just shared it in the chat.
Oh, yeah, sure. Just put together some notes because my bit of an issue I have with this kind of overlay tree method is that there is some kind of details that are not very terribly well specified, at least in the resources I could find. Pretty much everybody has some kind of idea of what overlay tree means, but it's probably a good idea if we all agree on what this actually means. And while thinking about this, I thought about sort of as a more of a generalized overlay tree or method for the transition. This is not, I mean, put some document, you can maybe go over it and read it. It has some kind of alternative ideas about how to do things or some kind of alternatives. I don't think we should, I think we should basically push forward a certain more narrow path, but it's good to have some kind of alternatives in mind. With that, maybe I can share my screen and just go through sort of some of the thoughts because it sort of affects stuff. Maybe I can do this. Can I do this? Chrome tabs, way too many tabs open, you know, this kind of problem. Cancel maybe. Yeah, maybe just share some screen. You can see this. Oh well. I think it works. Yeah. Just to sort of make sure what I understand what the overlay method means. For me, this kind of overlay method is just that at least during the transition time, we have multiple trees, and sort of some trees have precedence over others. And when we sort of, and then we somehow need to make sure that all the old data, which is currently in Verkle partition tree, ends up in some Verkle tree. And there is really multiple ways of doing this, like depending on how many trees you want to end up with. Maybe you want to end up with 2 Verkle trees and sort of go to some kind of state expiry compatible setup. You could do this. I think not. It's not probably not, but just to make sure that we can do this. And there is there's a bunch of points I want to sort of really focus on now, which is there is, I mean, this document really asks a bunch of questions that we just need to sort of agree on. I think for most we have kind of very clear direction. One thing, this is something we need to sort of make sure is that technically we want to freeze the Verkle tree. And just one observation is technically we only need to freeze the Verkle tree keys, not the values. We could, in principle, have some version where we modify the values under the Verkle tree, provided we don't touch the keys themselves. This sort of allows us a bit of leeway. The other thing is sort of related to pre-image distribution. I mean, there was this kind of thing that we either, there's an EIP now, I think it's EIP 6873, which basically says that we should probably, before we freeze the Verkle tree, we should start recording at least the more recent pre-images. The other option is, that was, I think I put it up last time, that basically once we freeze the Verkle tree, we wait for a certain amount of time until at least the actual point where we froze the tree has finalized, and which gives us enough time to actually distribute the total set of pre-images via some other channels. Yeah, I think it's why would the just to answer the chat, if the Verkle blobs carry the pre-images for the account slots it touches, we only need that for we only need the pre-images for those that we convert via sweeping, because we really have three ways to actually convert. We convert everything that we touched as part of the execution layer, but we also convert everything, even stuff that is not touched by the execution layer. For the stuff that is actually done due to reads or writes, we already have the pre-images. They are in the blobs, in the blocks. We only need that for this stuff that we actually don't touch, and this can be quite a lot. And it's kind of wasteful. And I mean, this is basically some fixed amount of data. Once we have frozen them, and the MPT, it's just some fixed amount of data that we really don't want to waste block space to disseminate that. Seems kind of wasteful to do it like that. Hope this answers your question, Q1 Tech. So yeah. Yeah. In particular, this means I would not do because a big advantage of actually freezing this is that we don't have reorgs crossing the boundary between Verkle and Verkle, which might change the set of keys, and then because we have to iterate over them, everything gets super messy. Having this finalized, I mean, I'm not an implementer, but I would expect that this makes every implementer's life much easier. So this is also why I would prefer that over EIP, over EIP 6873, and would in fact not go with this EIP for that reason. The only issue is, of course, if we want to have enough time to distribute this via a separate channel, we need much more time, preferably even some time to put in some emergency release if needed, which if you sort of have a time scale of 15 days for the whole transition, actually makes a big chunk out of this whole time. Question whether we want that or not. It's more of a timing question. I have no particular opinion on that. Maybe you have. What do you think about this? Then there is some stuff that we will have to actually care about. I mean, one thing is that I think it's currently always assumed that whenever we read something and we don't find it in the Verkle tree, then we look it up in the Verkle tree. If it's there, we actually also convert it. So we convert on read. I'm not sure whether we should do that. And this is a bit of an open question that I just want to put up. It has pros and cons. Personally, I'm leaning towards not doing it because it makes it easier. But yeah, may think about it. The other thing is, this is a bit of a contentious issue. In theory, when we write data during the transition phase, there is a bit of a question. I mean, if we add a new key, then of course it goes to the new Verkle tree. That's completely clear. But if we actually add something to a pre-existing key, there's actually really two options. You can either write to the Verkle, the new Verkle, or you can actually modify the pre-existing Verkle tree. Not sure what is actually the best here. This is something you need to consider, and how it interacts with the sweeping. There's a bunch of questions like when you do this when you iterate over all your old Verkle keys, you have to make sure that, yeah, if I actually convert something that may have been converted already due to some write operation, you actually have to take that into account. And this also affects some question. Yes, Guillaume?
Yes, sorry, I wanted to initially answer everything in bulk, but at the same time, there's a lot of questions being dropped, so I'd like to address this one. The problem with not converting on read, being able to update the Merkle tree, like just doing the sweeping and updating the Merkle tree still means you still need to have two Merkle roots. Well, you need to have one Merkle root and one Verkle root in the block. So you need to change the block format. It's a bit of a pain, at least to implement this and guess, well, okay, I guess you could put the root at the end. Yeah, you could do this. But it effectively reserves a field in the block header that will only be used for like 15 days or 5 months. The other problem with this, and it's actually the much bigger problem, that means you still need to have two concurrent snap syncs instead of having one. Because if you have a single, like if the Merkle tree is frozen, you just download the data and you're done. And then you Verkle sync, like you snap sync the Verkle tree. if you still keep updating the Merkle tree, yeah, you have to. It gets more complicated, basically.
Yeah, I mean, I'm not in favor of actually writing to the Verkle tree. Let me be clear. I just wanted to sort of write out a sort of an overview of the design that within the overlay tree method. That's just the purpose of this, just to be clear. I'm in favor of basically keeping it frozen because it's I'm in favor of the easiest way we can do it. Not squeezing out some minor efficiency gains here and there. Just not sure about the conversion on read. I'm not sure what the problem is with the conversion on read. Why this would complicate things. You know?
It's not complicating. Complicating things. It's in fact making things a tad simpler. But the problem is always the fact that you know full well that computing, like, if in order to check in the, like, if something is present in the tree, you need to pay the computation cost.
Yes.
And I would say might as well bite the bullet and do the whole update at the same time.
Yeah, I mean, sure, it saves computation. That's clear. It's just, but at the same time, it might make things a bit more complicated because you have, when you do it actually all this sweeping conversion, you have to make sure, you have to basically take into account that some stuff has been converted due to other means, whether you want that or not. And then the other question, I'm not sure what the current implementation does. The number of nodes that you actually convert, I mean, that's a bit of a question. Currently, we have, I mean, I think, I'm not sure what your experiments are. You only doing sweeping, or are you also doing some concurrent reads and writes? How are you doing this?
No, I mean, not concurrent for sure. It's like they're sweeping. So currently at the end of the block, but it can be done before. That's not a problem. And then the execution of the block. Sorry, before the execution of the block that does all the conversion, and then do the sweeping at the end, the 10K blocks.
Yeah, I mean, there's just a question about this kind of timing issue, that in principle, if you sort of are IO bound or whatever, we could make the number of leaves that we basically convert dependent on the amount of work that is currently done in the block. If we follow Dankrat's suggestion that we sort of make some extra allotted time slot, then which I would just go with, just make a fixed number and do with it. And if something has already been converted, just skip it. It's just something that we need to decide on something. That's just the other thing. And there's just one thing I wanted to note. I think it's never been mentioned before. In principle, it would be possible, not suggesting we do it, but just make clear that it's possible, that we could actually have some kind of overlay tree method that ends up with two Verkle trees. Basically by saying, yeah, we actually convert from some old pair of Verkle tree to a new Verkle tree, and at the same time we sweep from an old Verkle tree to a new Verkle tree. I think it's actually the easiest way to do it. The downside is we end up with two trees, and we don't want that. That's just all I want to say here. Yeah. Just to make these things a bit more clear. What I'm not quite sure, and something that we need, yeah, thanks, Lucas. What I'm just, one needs to care about a bit with this sweeping method is that how reorgs actually affects this kind of sweeping, and how much extra IO you actually have to care when you're doing a reorg. When you reorg all of these transitions, that you don't end up with some kind of completely bottlenecked by IO at some point, in order that we lose finality for some time because we have a big reorg and all of our nodes can't catch up with the extra IO from reorging all of these kind of transitions, just to make sure that this doesn't happen. That's basically my main concern. Thanks.
Yeah, so for IO should not be a problem because you have less nodes to read. Computation could be, I mean, yeah, I would have to think about it, but I think, like, intuitively, I would say IO would not be the problem, would not be worse than it currently is, because you need to load less stuff.
Yeah, I mean, in principle, it's a bit stupid from a certain point of view, because if you sort of reorg into some other branch, you're actually converting the exact same leaves. But still, I mean, you may have to redo all the work. It would be nice if you can sort of avoid that.
So you don't need a Merkle tree to actually do the conversion. I think the only flat storage is needed. So you can like drop the Merkle tree like at the beginning of the conversion and keep only the flat storage. I wouldn't delete from the flat storage unless finalized, maybe, just to keep the reorg simpler. So the flat storage is not kind of being reorged at all. And we can delete, so only you can delete only the things you kind of swept, right? You kind of converted during these between blocks conversion, let's say like that. And because this is like linear progressing. And in terms of reorgs, well, reorgs on the Verkle tree will be like normal reorgs or Verkle tree. So it's just as any other reorg on Verkle tree. So this is being covered, so it's simpler. So I would just gravitate to being this as simple as possible in any of those answers.
Yeah, same here. Just not sure about the conversion on the read because this is kind of not too clear what this implies.
Yeah, I wouldn't do conversion on the read. Just it's simpler because you'll still like you have to go sweep through all the keys, right? So whatever, right? Why do on the read when you will still get it on the going through the keys? It's like doubling the work potentially. One thing that is actually a question mark here is pre-images, right? This is the least defined thing for me, how to distribute it. And I think it should be distributed through peer-to-peer, through some kind of sync method. But yeah, that's an open question. And this sync method should be deployed on mainnet. It can be without a hard fork, right? We don't need a hard fork for that because it's like adding a sub-protocol. But it should be deployed way before the transition starts, like months. Or
you mean the protocol or the actual pre-images?
Well, before the transition starts, the pre-images will change per block potentially, right? If we add a new account. Yeah. So they are not fixed. They are not a fixed thing. They are evolving thing. So let's say someone starts syncing just before the transition starts. He has to be able to sync, get all the pre-images that are up to this point in the time. So I would say this has to be like a pre-image sync protocol that the network would serve. But that's my opinion.
Sorry if I may butt in. There's so just getting back to backtracking very briefly. I actually in the prototype I've wrote there actually are no conversions on read. So I got confused, but actually we don't do that. So this is indeed the simpler version, and this is what is currently being done. So those numbers are with no conversion on read. Getting back to the pre-image problem, indeed we can do we can distribute the pre-image either via the peer-to-peer protocol, or we can even do it via CDN. That's what Pari was suggesting. The thing is, you only need the pre-images for the moment that the transition starts. So there are several reasons why the conversion would start. Actually, that's not true. Yeah, okay, sorry, I got confused. Right, you would indeed need to start passing the pre-images, but the enabling of the pre-image recording and just like what you need to do conversion on write would be done. Yeah, could be done without the protocol itself. Like every time you execute something, you know the pre-image, so you could save it and you could use it directly. Then there's indeed everything that was not accessed during that period, preparation period just before, and that we need to distribute. I don't really care how we do it as long as it works. You were saying how big are the pre-images, Enrico? It's currently, at least for Geth, it's currently 70 gigs. but it's all the pre-images, some of which are not being used because they were used once in the past and never got accessed again or got deleted or something. So it's probably smaller than that.
So upside of doing it in peer-to-peer is that it's self-contained, right? It updates all the time, and if you like, if you sync whatever time, you have it. If we sync it through some kind of content delivery network, then we would probably have to do it in a way that we stop writing to Merkle tree, start writing to Verkle tree. In this time, the pre-images appear somewhere to be available, and you have time to download it before you start to have to do the sweeping part.
That's exactly the suggestion. Yes.
Okay. So, but that's like potentially unreliable, right? To some extent, we have to like have a quite big window for that.
Yes, that's exactly what I said in the beginning. Ideally, we would have this window big enough even to squeeze in an emergency release, which may be something like 2 weeks or something. So out of the total time for a transition, if the whole transition only takes 15 days, it makes it factor 2.
Okay, maybe then it might be simpler. But yeah, okay.
One of the questions I had is, you say it's being it's updated. Like if you have the peer-to-peer network, you can update it. That's true, but then don't you need to implement something like SnapSync effectively? Because how do you know how out of date the thing is?
Yes. You have to have this kind of yeah.
Mm-hmm. Okay. Yeah. I mean, clearly, I'm not going to.
Oh, okay. For example, you can modify Eragon to have like deltas of pre-images and just download them, right? So for each block, you can very easily know what kind of items were added, right? And you can very easily download it by indexing by block. So you know which block you are, and you can download all of them backwards.
True.
Very simply.
And yeah, and you could also download like a huge flat file at some point. Yeah. Like just get the updates basically. Yeah.
There's a question from Gajender in the chat. I don't know, Guillaume or Gottfried, if you have any thoughts on that.
Well, I mean, you could, of course, do that. It's just more complicated. Just to say, I mean, if you sort of make this calculation part of the Merkle state, I mean, this would be the idea that everybody has to do this calculation, which is quite heavy. And it just adds one more thing that we need to think about, which is, I mean, there is not, I don't see really much point about this, much benefit of doing this, except that we don't have this extra time. I mean, my take on this is that the main advantage of actually only having to distribute pre-images for a frozen Merkle tree is that there is no reorgs around the transition period. So basically working with a frozen Merkle tree when you do the sweeping actually has the main advantage that this doesn't change, because I mean, remember that you need to sort of sort this also into the correct order to basically make the sweeping consistent. And this can get messy if you have a reorg around that. Yeah, Guillaume?
Yeah, no, I don't have anything to add to what you said per se. I just wanted to point out that there's actually a proposal by Vitalik that you do exactly this for the Verkle tree in case you want to change again in the future. And this is something that's a bit annoying because you need to evaluate to do a multi-x of 2 more values, the address and the slot number. But the great advantage of this is like the pushback I got from members of the guest team, especially Martin, was that this new model where everything is spread over the tree. He was saying it's hard to debug because it's hard to, when you look at a group, you can't really trace what the which account it came from, etc., etc. So doing this, although I'm not a super fan because of the extra computation involved, would probably get us a better buy-in, let's say, from at least from Martin. So it's not completely irrelevant, I would say. I mean, yes, I would not do that for the MPT, but there's still definitely a good reason to do it.
Okay. If there's nothing else, then we can move on. Thank you, Gottfried, and everyone for the discussion. Ignacio, did you have an update on performance work that you would like to share?
Yes, I will share a document in the chat. So maybe some of you have already seen this a while ago. So this is like a new version. And I will only mention like the end result of doing the changes because the actual details might be a bit boring for most of people, I know. So I basically implemented a bunch of missing optimizations in our Go cryptography libraries that are basically, many of them were like already known out there in some documents that get wrote or some articles by Dankrad. There were like others that I discovered by looking at the implementation in Rust. And there are like others that I simply identify while digging in all this. So in this document, basically, if you go into the impact section, there's like a brief summary of what kind of speed up you can get from like a semi-naive implementation that we had, that we already knew that, to one where you apply all the ideas. And what we got is basically for an example of 16,000 polynomial openings, we have like 2.5x speed up for proof generation and like a 30x speed up for proof verification. So after sharing this a bit with some people, it seems like this is at least in better shape now, at least what we were expecting. So there might be some other ideas that we can do to improve the numbers a bit more. But that mostly relies on parallelizations and things like that. All these optimizations are mostly single-threaded and doesn't require extra memory. There are no like more pre-computations or things like that. So yeah, I went into more detail in the document about what are all these ideas, and I kind of linked the ideas to PRs that implemented that. So this might be helpful for the future other people like implementing things or trying to figure out what the Go code is doing. If they want to copy that, at least have a more like coherent explanation of the ideas. So yeah, that's my update.
Thanks, Ignacio. Okay, cool. So one thing that I had that I wanted to share, just a quick thing, I will share it in the chat. This will only take a minute. I thought it could be helpful to put together a quick overview document of open questions around Verkle, or perhaps more accurately, known areas of work that have not yet been fully spec'd or implemented. I won't go through each of them here in detail, but if anyone has any questions on these, has areas that could use more attention, or anything that's just completely missing from this list, I would appreciate that being flagged. You can do it here in chat or in Discord. Really just trying to make sure that we are staying on top of everything and that things that should be getting attention at this stage are getting the right amount of attention. Obviously, there's still a lot that needs to be done as we get further along. But yes, so I just wanted to share that quickly. And I'll share an abbreviated list here in the chat. Cool. So that was it for me. Going back to the agenda. Oops, I just lost my cutting. Yes. Tanish, did you want to share a quick update on Verkle SnapSync work?
Yeah, I think I can give a brief explanation of what I'm trying to do. I don't have a document yet because it's still in prototype phase and still have to figure some things out. So the idea is very similar to what we do in SnapSync for Verkle trees, but there are a few differences. Like first is the healing part. So since in Verkle trees, every block have a post state and proofs inside the blocks, we don't need healing from, like, we don't need additional data from other nodes to heal the tree while syncing. So one difference is that we can just use the state diffs or witnesses in blocks to do the healing part. Now coming to the actual sync part, yeah. So what I'm planning or what I'm prototyping right now is that instead of fetching the range of leaves, we instead fetch the range of subtrees. Like basically, with 31 byte stem, we fetch the entire subtree as one element. This makes the proofs that we need, the range proofs that we need for Verkle trees much simpler. Yes, so I'm experimenting with both of these, like with fetching ranges for leaves and fetching ranges for subtrees, and we'll update on the difference in proof sizes and the time it takes to sync. So I was able to run some tests, not on two different nodes, but some unit tests and things like that, and this seems to be working properly. But since in Constant we still don't have the post state in the blocks, so I cannot test the healing part right now. But I think I'll have some more updates on this before the next week.
Yes. Yep.
Sorry, yeah, thanks. Yeah, that's true that in Castilian you don't have the post state. I'm just wondering, would there be a way to somehow, yeah, I mean, I realize that this question might go, I mean, is a bit stupid, but could we just not try to have the, like, the snapshot that would correspond to the pre-state instead of the post-state? I mean, clearly, the problem is you find yourself with a patchwork of blocks that need to be executed in different locations, so it's a bit complicated. But I'm still wondering if we could try to. Yeah, okay, it's probably not actually. Come to think of it, it's not really worth it. Yeah, because it's only for Castilian, so it's not really going to be worth it. Okay, sorry.
Were you proposing that we use the pre-state and execute the block and use the post-state to do the healing?
Oh, sorry. Yeah, that was more or less it, but then it's going to be like a full sync, so kind of kills the point. I mean, as an intermediate step, it might be interesting, but yeah. I mean, you tell me, but I think it's too much work for too little gain.
Yeah, it depends, like how much time will it take to implement. I'll try to first prototype the current ranges part, and if I have some time left, I can give it a try. Because anyways, we are processing the block while verifying the block. So I just have to add one additional structure that collects all the updated leaves. I think it should be doable. I'll give it a try. Yeah.
Sorry, yeah, you would be processing the block, but I mean, ideally, you would want to start. You know, if for example, it's 2 years from now, so like 2 years after the transition, and for whatever reason we don't add post state in the blocks, that would just be a full sync. It's true that in the short term you will likely just re-execute the blocks, but you want to start from a clean for something stable that is the correct state, and that might be yeah, Lukash.
Yeah, but it will be only full sync for the blocks that were added during our snap ranges part, right?
True. Yes. That's
Yeah,
true.
so it will normally it can be like on fast machine, it can be like 2-3 hours of blocks, so not that
Yeah.
many blocks to reprocess.
Mm-hmm. Yeah, that's true. Okay, it might actually be worth trying. Yeah. Yeah.
Yeah, it would be. And anyways, we have because eventually we'll be adding post state, so we have the mechanism to collect the updated leaves. We just have not enabled it yet in Gaussian, so it's already implemented. So I don't think so. It's a lot of work. So yeah, we can give it a try.
Actually, Anishka, I have a different question. Can we process those blocks? We can during snap ranges.
Yes, that's exactly what I was thinking right now. Yeah, we can process those blocks during the sync. Yeah.
Yeah, so these blocks will generate us the newest value, and all the old values would be from snap ranges. This will be kind of similar to the overlay tree transition a bit.
Kind of. Yes.
Right? So we keep the new values from the processing, and the old values are coming there from overlay, and they're in consensus, and here from the snap ranges, and they are not in consensus. Yeah, overlay snap. Yeah.
Oh, that's yeah. Very interesting. Yeah.
Yeah, so I would say go for that, right? Because that would also decrease the time to sync. So that's should be implemented without a doubt. Either with
Okay.
processing or with what? With post state, right? But why not processing? Why, right? We should even do processing, because this allows us to verify the chain right when we start our node, right? So why not?
Yeah, makes sense. We'll anyway be processing those blocks, so we can do it while syncing also.
Exactly. We should do
Okay.
that. We should do that. Definitely.
Okay. Yeah, sure.
Okay, the last thing I had on the agenda in these last few minutes is to see if there are any updates from any of the client teams or any questions, anything for discussion here. I don't know how much progress has been made. I know everyone is busy since our last call a few weeks ago, but if anyone has anything they'd like to share, it can be anything.
Hey there. I'll be working on Java implementation of Verkle tries, and I'm just starting, so sorry if any of the questions are stupid. But yeah, my first question is Can we use other languages implementations of cryptographic primitives like inner product argument and Pedersen commitment? Because we will do this in Java. So any feedback? Yeah.
Yeah, so there's the Rust implementation, Rust Verkle, that contains all that stuff, more or less directly. Maybe it imports other packages, but you should be able to call that through the GNI. Yeah, like Kev would be the guy to ask. He's done that for like this is how Nethermind started, so it's definitely possible.
And yes, we have a repo in Bezo. It's a Bezo native repo. You have some sample to show you how to use the Rust library, Go library, or C library. So if you look at this repo, it will help you.
For Java, it might be a bit more difficult because, as I understand, you need a .jar file, which means that you need to compile for Windows, Linux, and Mac, and then at runtime you choose the operating system you're on. So it might not be as simple as sort of C#.
Yeah, Normally in this repo we have all of this mechanic to build for all of the platforms. So you just have to add the new library, some configuration file, and everything will be did without any problem. So
Okay, nice.
so Dragon, I can show you in the next meeting if you want, or in the Telegram if you want more info.
Yeah, there is also recently our KZG library in Java that deals with the same thing. So it's built for different platforms, and then the GNI wrapper, just choose the right one. Yeah, it could be another reference.
Okay, thank you. I will investigate on all of those.
Are you planning to implement, planning to do everything using the wrapper or just some functions?
I'm still not sure. I'm just learning about all of this stuff, so I don't know yet.
Yeah, so that's what I was trying to say. So when I I also implemented the wrapper over the Rust library and started using that. But the amount of operations that you need to do on the cryptography to calculate commitments and update commitments, it kind of end up being quite a lot slower than what is implemented in Rust due to the FFI boundary. So you might want to look at like what functions you want to actually outsource to Rust and what you want to implement in Java. Because I eventually ended up implementing everything in C# because of that.
In general, we are in Bezo. We are trying to do all of the cryptographic stuff in the native code or something like that, and the Java will just be the tree structure definition, or how to manage the Verkle tree implementation without the cryptographic stuff.
Maybe I misunderstood. You said the native implementation would do the cryptography. Does native mean Java here?
No. When I'm saying native, it's just C or something like that. Yeah.
I'm planning to sort of get my hands dirty and try to sync the ongoing Verkle testnet with Lodestar.
Okay, I think that is it then, unless anyone had anything else. Thank you very much, everybody.
Thanks, bye.
Thanks. Bye.
Thank you. Goodbye.